All right, now let's take a look at example number 3 from lesson 4.3. A penguin population on an island is modeled by a differentiable function p of time t, where p of t represents the number of penguins and t is measured in years from t equals 0 to 40 inclusive. There are 100,000 penguins on the island at time t equals 0. We are given that the birth rate for the penguins on the island is modeled by B of t is equal to 1,000 e raised to 0.06 t penguins per year. Again, that is a rate. Oops, that is a rate. That's the birth rate. And then the death rate is also given here. D of t is equal to 250 e raised to 0.1 t penguins per year. Now you're asked to find what is the rate of change of the penguin population on the island at t equals 0. Okay, from the previous example, okay, we know that to find the rate of change of the penguin population, you have to subtract the number of penguins that are born, okay, at time t equals 0, minus the number of penguins that die at the rate of change of death. No, wait. Birth rate at 0 and death rate at 0. You have to get the difference between these two. Now, basically, it says here you can use calculator, but this is true for the other problems in example 3. But for this particular problem in A, since your t is equal to 0, so what happens to your B of t? B of t is 1,000. E, if you plug in 0 for t, your exponent becomes 0. Same thing here. If t is equal to 0, then that reduces 250, the death rate, e raised to 0. And we know that e raised to 0 is 1. So therefore, this is equal to 750. Okay, so this is the rate of change of the penguin population at t equals 0 is 750 penguins per year. And that's all this is asking.